Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning was I wanted to go over with you a program I made on Google Colab, and I also put it on Kaggle, and then I've also put it on GitHub. The thing about Kaggle is with Kaggle, you're only allowed to have 10 submissions a day. And because I used all of my 10 submissions, I'm not allowed to submit anymore. And that means that I wasn't able to get my best score on the leaderboard. And if I had been able to get my best score on the leaderboard, then I'd be showing you my Kaggle submissions. But the screen recorder I have really only seems to work when I'm on one tab of Google Chrome. So I just decided to stay on GitHub. So what I did was on tomorrow night, when I get up in the middle of the night, I'm going to resubmit my submission, and it's going to have with the lasso command, and it's going to have an alpha of 102, and that's going to give me a score of 0.1425, which was as high as I could get it. But because I had to experiment with the alpha values, I'm not on 0.1425 at the moment, which is why I didn't want to show it to you on Kaggle. But I will whenever I do get my top score on one of the competitions I enter. Certainly I will give you the presentation on Kaggle, but I can't submit my work until tomorrow night because I've used my 10 submissions. So I've uploaded my program on GitHub, and you can see this is my page, and we're on house prices, and the program name is Amy's Housing Prices Without Scientific. So the first thing I did was I uploaded all of my libraries, and you never know which library you're going to need when you're programming, so just better safe than sorry. I uploaded more than what I needed. And then I uploaded some more libraries. The module that I really needed was linear analysis, but what we used a command called lasso, which is a type of linear analysis. So the first thing I did was I uploaded my data sets, and you can see this is the data set with Amy's housing prices, and you can see it's got a lot of columns in it. So I did the command dftrain.shape, and that tells you it has 81 columns by 1460 rows. And I did dftrain.info, and that tells you about this file. And you'll notice that there's quite a few non-null files. So any cell that's null, you've got to correct that and put something in it. Otherwise, the computer program won't work. But we're going to deal with that in a little bit. And what I did was I described my DF train, and so the describe gives you the statistics of count, mean, standard, minimum, 25%, 50%, 75%, and max. And so it gave you the statistics of this data frame. And the next thing I did was I loaded the test file. So the test file has the identical columns to the train file, except for the fact that it does not have a price column. So it has 80 columns by 1459 rows, which you can see that when I did my df.shape and my df.info. That tells you a lot about this data frame as well. And what you want to do is you want to get rid of all of the null values in this data frame as well. And I described the test file just like I did the train file. And one of the things that we did was we described the sale price, because the sale price is what we're going to be looking at. And so we don't have a sale price for the test, so we described the sale price for the train file. And we plotted the sales price, and you can see where the sales prices peak. They peak at like maybe $150,000, something like that. And then we plotted the sales price against the greater living area, and you can see the plot. We plotted the sales price against the total basement SF, and you can see the plot. We did a box plot with the overall living area against the sales area, and you can see that plot as well. And one of the last things we did was we did a heat map, so you can look at the heat map to see where all the values are. So we defined our Y value as being DF train sales price dot values, and we combined the two files, the train file with the test file, and we dropped the sale price to combine those two files. And then the next thing we were doing is we were looking for any null values, and so this is some programming here to look for null values, and this is the data frame that was made to show you any null values. We looked at the info of the combined file, and again, it's just showing you any null values in the data frame. So now what we wanted to do is we wanted to fill up all the null values with the average score. So we filled up MS zoning with the average score. We filled up alley with the average score. We filled up utilities with the average score. We filled up exterior 1 and exterior 2 with the average score. We filled up mass center type and mass center area with the average score. We filled up basements with none. Anything that had an NA, we make none. We filled out some more basements with none. Filled out electrical with the average score, kitchen quality with the average score, fireplace QU with the average score, pool QC with the average score, miscellaneous features with the average score, fence with the average score, functional with the average score, lot frontage with the average score, and then the garage business, if it didn't have a value in it, we just put 0 in it. And then a sale type, that if anything that had no value in it, an average score was put in. And the next thing we're going to do is we're going to check to see if that data frame has any null values, and we came up with 0, so that means that it doesn't have any more null values. So again, we did another DF Combined .info, and that shows you that there's not any null values in the data frame. So here's another programming code that we used to change the type of some columns, so to make sure that the program will work more efficiently. And then we did another program called we dropped the ID of the combined file, so the combined file no longer has ID. And we did a command called get dummies, and that's just to try to prepare the file so that it can be used for processing. So this is your DF Combined file, and you can see that the IG has been dropped, and now it only has 79 columns. We've got a result is the combined dummies values, and now what we did was we wanted to predict our sale price. So the independent variable was greater living area, and the dependent variable is sale price. And so just wanted to see how many dimensions the array had with X, and it has 2 dimensions, and Y has 1 dimension. And now we created a matrix, so we can we created a matrix to enable us to predict the sales of the properties in the test price. So we used some standard configurations of X train, X test, Y train, Y test equals train test split, which includes X, Y with a random state of 42. CLF is lasso, and alpha has a figure of 102, and that's what I had been experimenting with on Kaggle, and that's the figure that I could come up with to give me about the best score on the leaderboard, which I'm not going to be able to put that value in until tomorrow midnight, sometime around that time. So I'll get my 10 submissions again, because in Kaggle you're only allowed 10 submissions a day, and unfortunately I used all of my submissions today to try to find the optimum score, which I didn't do that before I used up all my submissions. So you got cl.fit equals X train, Y train, Y pred equals CLF predict X test, Y train pred equals CLX predict X train. So that's your formula there that enables you to perform the lasso function to carry out your calculations. So you're going to print your scores. So the test and train scores were 93 and 90 respectively. And then you're going to print some more scores, and that was 93 and 90 respectively as well. You're going to, final labels is going to be clf.predict text values, and then you're going to, final labels, you're going to call up an array, and this is your array that it comes with. So final result equals pd.dataframe, and then this ID is your first column, which comes from DF test, and sell price is your second column, which comes from final labels, because that's your prediction. So final result is going to go to a CSV file called submission CSV, and you're just going to print a little message to say your submission was successfully saved. And then you're going to upload your submission, and the submission equals pd.readCSV submission CSV. And what I've done is I've printed out the submission so you can see what's going to be submitted to Kaggle. So that's it for this program, and you can certainly follow along with me to see my methodology and how I worked. And I'm going to be doing some more work on Kaggle and experimenting with other functions that I can use to predict the price to try to get my value up. I just wanted to show you what I did to demonstrate the program that I wrote. And the lasso, the value of 102 alpha on the lasso is something that is definitely my work. That's something that I found out. I found out that when you use the lasso command, in order to get an optimum result, you need to have an alpha score, and I found that out on my own, and then I had to experiment with alpha scores to try to get the optimal rate on my leaderboard. And so that definitely 100% is my work, because some people say, oh, well, you've plagiarized somebody's work. But the problem is that when you're just starting out, you have to look at other people's code and copy other people's code to try to find out what you're doing, try to figure out what you're doing, and try to learn how to do it. So I did actually have to look at other people's code to prepare this program. But the alpha equals 102 on the lasso command is definitely my work. It's definitely something that I found out on my own. But so if you decide to use this methodology, you'll have to experiment with your own alpha values, because your alpha values might be different from my alpha values. So I'm going to conclude this presentation for now. Let me know what you think about the program that I wrote, and it's a submission to Kaggle. It's the house prices submission, and let me know what you think. If you like my video, please like, subscribe, and share. If you like the work I'm doing, I've got my email address down below with my PayPal account. If you want to make a donation to my PayPal account to help defray my expenses, which are numerous. And thank you so much for watching this video, and I will see you the next one.